Good morning, everybody. It's Mr. Scala coming at you via screen recorder. All right, so today in the virtual meet, so we were going to start off by sharing some inventions. That way, some people are able to share their ideas. Some people are able to gain some ideas from other people's. Collaboration is key. Looking at the number of responses right now, I only have 74 responses out of the 120 plus kids that are in this Google Classroom. So remembering to get our work done and get things turned in. All right. So this part of the graphic organizer that is in Classroom has been the most confusing part for students in the past. So you're going to organize your thoughts and ideas, and you're going to do that using a chart. In this chart, we have our STEM, science, technology, engineering, and math. And right here is where you're going to put your invention or innovation. So it could be your whatchamajig and thingamabob. And regardless of what your invention is, all of them are going to include science, technology, engineering, and math. So science, what kind of science is needed for your invention? So you have all found a problem and you've come up with a solution. So you've found a problem and you came up with a hypothesis. You are also going to be testing and problem solving. All of those are examples of the ways that science comes into play when you're creating something and for your dream invention project. Technology, what kind of technology will you need to invent or innovate? So, things I might put down, you're going to probably use technology in creating it. You're going to use technology in advertising, use technology in improving, and use technology in actually coming up with a prototype, sketch, or drawing. Engineering. What makes the design of your invention difficult? Draw it. Well, right now we're not going to draw it yet, but for this, so my examples and ideas are, well, you're naming and making ways to improve upon a problem that you see. You're designing something. You're creating a prototype. You're problem solving and you're building. Math. A lot of people wonder how math is a part of their engineering design process and in their dream invention. Well, for math, you're going to be measuring sizes, collecting data on how well your product is doing. You're going to use data for your trials and you're using it as a comparison. So for in your advertisement, let's say you want to go the traditional Colgate route. Colgate is toothpaste. So 4 out of 5 dentists recommend blah. So like Colgate. So you're using all of these in your dream invention project. And we're going to be able to explain it. So what is the engineering process?
How do we get around from place to place without having to walk everywhere? How can we communicate with people who live far away? These were problems that people struggled with for a long time, until recently, before there were things like cars and phones and computers. And you know who solved those problems? Engineers. But do you know what an engineer is? The short answer is that an engineer is someone who wants to know how and why things work. Now, I want to know how and why things work, but does that make me an engineer? Not quite. Besides being naturally curious, an engineer is a person who designs and builds things, like machines or systems or structures that help solve a specific problem. There's more than just one type of engineer, too. But no matter what type of engineer someone is, they have to ask themselves 3 very important questions when they're working. Number 1, what is the problem that needs to be solved? And number 2, who has the problem that needs to be solved? And most importantly, number 3, why is this problem important to solve? Let's take a look at some examples. A really famous example of engineering is the Golden Gate Bridge in San Francisco, California. I mentioned that there are different kinds of engineers, and a civil engineer is someone who designs and constructs buildings, roads, and, bridges. For the person who designed the Golden Gate Bridge, What was the problem that they needed to solve? People couldn't travel in or out of San Francisco, which is surrounded on most sides by water, without a boat. Who had the problem? Residents of San Francisco mostly, but really anybody traveling in the area. And why was the problem important to solve? Well, you didn't want a whole bunch of San Francisco residents trapped in San Francisco forever, even if it is a super cool city. Plus, you wanted people outside of San Francisco to be able to travel to the city easily if they needed to. So the Golden Gate Bridge was engineered as a solution to this problem. In addition to civil engineers, there are also mechanical, electrical, chemical, computer, nuclear, and software engineers, and the list goes on. Let's talk about what some of the other types of engineers do. First up, electrical engineers. Electrical engineers study electricity. They design electrical systems like circuits and computer chips. Think of an electrical object that you use pretty regularly. How about your microwave? What problem was the microwave a solution to? Cold food, right? You have an electrical engineer to thank for the ability to reheat that leftover pizza you just had for lunch. But while you might not have heard of Joseph Strauss or Percy Spencer, the engineers responsible for the Golden Gate Bridge and the microwave respectively, you've probably heard of Henry Ford. As in Ford cars? Henry Ford was a mechanical engineer, or someone working in the manufacturing industry, making mechanical things like tools, engines, and machines. Machines like cars. Ford didn't invent the automobile, but his Ford Motor Company made a lot of them. His Model T car was famous for being affordable for plenty of Americans. Ford saw that lots of people who wanted to drive cars just couldn't because they couldn't afford the pricey vehicles that were for sale. So he engineered a cheaper model as a solution to this problem. His fellow engineers started to do the same, and now, well, cars are everywhere. Henry Ford's not the only big-name engineer. A famous engineer around today is Marissa Mayer. Mayer is the president of the internet company Yahoo and is also a software engineer. Software engineers work on computers and other products that use software to write programs to make them faster and able to do more things. No matter what kind of engineer someone is, their job at its most basic level is problem solving. Each engineer just specializes in solving certain kinds of problems. While it might seem like there are too many types of engineers to keep track of, just wait 15 years, or 50, or 100, because we'll probably have a ton of different types to add to the list by then. Think about it. Over 100 years ago, we didn't have jobs in fields like aerospace engineering, where people design and construct planes and spacecraft. We didn't have planes like we do today or need spaceships, so we didn't need people to engineer them. Who knows what machines or tools or everyday objects we'll have in the year 3015? Personally, I'm hoping for underwater cities. But whatever these things are, we'll need engineers to make them. So what do you say? Who wants to be an engineer?
I do. In our second video is the engineer design process.
I'm gonna take a wild guess and say you've probably used the phone. And I bet you've enjoyed the benefits of a little thing we call air conditioning. You know who made those things possible? Engineers. We were just talking about engineers in our last video, people who design and build things to solve problems, and there are lots of different kinds of engineers. No matter what type of engineer you want to be though, civil, mechanical, electrical, or a kind that doesn't even exist yet, there's a series of steps that all engineers follow when they're trying to solve a problem. This process is called, wait for it, the engineering process. Makes sense to me. So what sort of steps are included in the engineering process, and why do we need it? Let's go through it step by step and discover how awesome things are made. First thing you gotta do is just define the problem. I mean, before you can solve a problem, you have to figure out what it is, right? For example, back in the 1800s, an engineer named Alexander Graham Bell was trying to come up with a simpler, cheaper way for people to communicate. Back then, the best you could do was a telegraph, which was an old-fashioned system of sending messages over electrical wires. Bell identified his problem. Communicating with people who were far away was expensive and took a lot of time. So his invention, or solution to this problem, was something you may have heard of. The telephone. Nice. Now, once you've figured out what problem you want to tackle, you need to do your research. You can start by just making a list of questions you have and what information you need to start answering them. You can also look around and find what other things already exist that have tried to solve the same problem. Maybe they can be improved. A good example here is the man who helped us blow stuff up. The chemist and engineer Alfred Nobel invented the explosive known as dynamite, not because he particularly enjoyed explosions, but because miners and other people who, well, needed to blow stuff up to do their jobs, needed an explosive that was safer to use. So before he started on that problem, Nobel did research to see what explosives already existed, which ones worked well, and which ones didn't. This takes us to step 3. Develop a solution. After your research is done, this is where you say exactly how you think you can solve the problem. And once you've thought of a good solution, you have to figure out how it'll actually work and what it will look like. So you have to design your solution. This is where you get to draw. Civil engineers always sketch out their ideas, like buildings and bridges and towers, to show what they'll look like when they're done. Gustave Eiffel designed the famous Eiffel Tower in France, and he definitely showed up on day 1 of construction knowing exactly what it was going to look like. On to step 5, build a prototype. A prototype is just a simple model that lets you test out your design. It can be as big as the real thing's going to be, or it can be a smaller version. You just need to have a prototype so you can test it. This may be the most important step in the whole process. Engineers need to test their design to see if it works like they want it to. So, say if your building's a big tower, does it stand up? Does it stay standing up? If you're designing something with moving parts, does it work the way you want? Now take it from me, my future engineers. You might have a great idea, a really terrific solution to a really big problem. But when you get to this step, your prototype probably won't work exactly the way you want. At least, not on the first try. Most engineers test their prototypes over and over and over again. That's why a lot of time and brain power goes into the very last step, evaluating your solutions. Evaluating just means asking yourself whether things are working the way you want, or why they are, or aren't. I like to think of this step as question everything. This is when engineers review all of the facts and ask themselves questions, followed by even more questions. What worked well? Why did it work? Why didn't it work? How could it be made better? And most of the time, the answers to these questions are going to send you back several steps. Like, once you figured out why your prototype wasn't working, you'll have to design a new solution and then build it and then test it again. Sometimes engineers go through this process 4, 5, even 6 times or more. Take Willis Carrier, the inventor of modern air conditioning. He tested his prototypes for years before he figured out the design that worked the way he wanted and solved the problem he wanted to fix. Like all engineers, he failed a lot before he succeeded. And that's okay, because he learned something from every failure, which made his product even better in the end. And I, for one, am glad he kept going. So the engineering process is a series of steps that engineers, or anyone, should use when they're facing a challenge. The process is important because it allows engineers to experiment and also to fail. Both of these things give engineers a chance to go back and improve on their original idea, giving us something even better down the road. So the next time you fail at something, don't feel too bad. Think about the telephone and the air conditioner and the Eiffel Tower, and then try again.
So, the engineering and designing process. So the design process is an interval process, which means these steps can be performed over and over again to get to your solution. So, we start at recognizing the need, defining problem, plan the project, gathering information, generate concepts, evaluate concepts, analyze, select the most promising concept, build prototype, test prototype, evaluate results. And a lot of time at this step, we're going to realize our prototype did not work as well as we thought it did, or it has some flaws in it that allows us to go back and recognize the need to solve those problems, those flaws that we have found out. Then you go back through it. This process can go over and over and over again and be repeated until we get our final product. So that is where we are going to stop for today. Remember, on the graphic organizer, you are just doing the top boxes. These ones right here. And keep in mind, if you get stuck, I would rewatch this video because I did give you some ideas of things you could put in each of these boxes. Have a wonderful rest of your day. Bye.